The weekend is almost over, and I am also back. I really had to take a break yesterday. You can hear it by my voice probably that I was not so fit, but I will also not be so visible today, but I quickly wanted to introduce the schedule to you. We changed it a little bit in the last minute. It's probably mostly relevant for team 2D to CO2, because we moved it to the back that some other groups find the connection, and connection found are closer to each other. But beside this, the schedule is very straightforward. You will have 5 minutes to present your challenge or your work, and then we will have 5 minutes Q&A from the jury and probably also from the audience. I'm very happy that we have, it moved too far. Jetzt zeigt irgendwas anderes. It's not showing. The jury. I quickly wanted to introduce the jury to everyone. We start with Ursula Frick. She is a very experienced computational designer, has a very good background in timber construction from the manufacturing, but also from the planning side. So I think since we have some groups really working on this, it will be very interesting to hear your thoughts on this. We have Ala Joost, who is founder and CEO of Beyond BIM, and he's a long-time digital enthusiast, I would say, in the scene around for quite some time. And he will give us his perspectives from the business side, but also from the data lifecycle point of view. And last but not least, Ronny Starnke. He's you studied informatics, right? You're a professor for informatics, computer science. So also someone who really can judge the work that we will see from this perspective. Thank you very much for being here. The stage is yours in a bit, so I would say let's get started. And we start with the first team. You're here already.
You. Fine. I can't see the screen. Memra, can you check? Oh man. Yeah.
It's a little bit sensitive, so don't.
Okay, just I will be very quick. Yeah. Okay. Hello, everyone. Thank you for being here. Today we are going to present open permits. We are proposing a solution for the challenge proposed by ESRI, which is automating compliance checks for building permits. Let's see the final overview of our proposal. So at the final stage, we will see the building which is not compliant on the related zone. So very simply, I will show you on live demo. Now I will upload IFC model on the live demo just here. Sorry, it's here. This is our interface. So okay. I'm choosing the IFC model here, and I'm processing the file, then continue to my presentation. Okay, yeah. So as we told you, here's the final stage. So before moving forward, just I have very quick question for any one of you. What is the approximate time for approval of building permits? Do you have any idea in your country or Switzerland? 1 year? 5 months from our team. So 2 months, yeah. So as per the research we have followed, it is going from 2 months to 2 years. And we take one more step forward and we are asking for the real question. What is the real problem here? The real problem is time-consuming approvals. So the problem is here, every area, they have their own regulated zones. So it is taking time to check the compliance with our models. So they have also limited accessibility on this building compliance. And when we are spending time on the building regulation, building permits, there are also risk of rejections. So on the next slide, as you see, we are proposing open permits. By simply uploading the IFC model, you can see whether it is compliant with the related zone or not. It is so simple. So we have many stakeholders that we are all can use it. For example, if you are a software engineer, you can take it and as a base and you can use on their region, on their country. So now my colleague Nilüfer will go and give more detail about it. Thank you.
Thank you. So I'm just going to explain the workflow a bit. So our process basically consists of 3 steps. The first step is always the input data that can come from different sources, geographic or text-based. Then we will have the evaluation process, which is basically the tool that we are developing. And the third part is the visualization of it, which can also be done through 2 methods. So here is a more detailed overview of the workflow. As you can see on the left side, we will have an IFC, as my colleague said, as an input file. And this IFC file will go through a Python workflow where at the same time, we are also including the building standards that we receive. This document is always available in the city or zone that we're doing the analysis. So one challenge is that we will have different data types, and usually the extraction of the information can be challenging. That's where we have used LLM to extract the data that we need for the building attributes. And through our Python model, we are doing the comparison and the compliance check. And one way we are visualizing the data is through a report, a basic and a standard way of showing it. On the other hand, we are also proposing a more user-friendly interface, and we are using a speckle for that. So through the speckle, we are receiving the IFC model, and from the Python model, we are also extracting all the building attributes. So within Rhino and Grasshopper, we are developing a geometric representation and also a geometric response. And then we will push it back to speckle. So that's where you saw in the first slide or the second slide a preview of the model. And this will be also the second way we are giving the users or the clients feedback. So as an overview, we use like a bunch of tools, as you can see here, and they're like for different topics, for example, for input, for analysis and compliance, for modeling, and also for sharing and viewing. And here I will hand it to the team for a technical demonstration.
We can quickly check that the model we uploaded before, the analysis is complete, and all the data that you see here could in the next step be exported as everyone's favorite PDF file. So we imagine that this platform can already be used from Monday to actually make an impact, and also is a very nice scaffolding to further integrate with other softwares, include more detailed analyses and more localized regulations from the authorities. And we can imagine it going even further with maybe mobile applications or AR implementations, and to push the adoptance. So as a wrapper, we were involved. We were asked to answer this challenge, a real challenge based on streamlining the zoning permits in between authorities and private stakeholders. And we answered this via an open source platform agnostic platform, web-based platform, which is scalable and allows for future growth and wide adoption, both from industry and government authorities. Thank you so much for your attention, and we're open to questions.
We can also open show the Once, yeah. Model. Hey, you can take, please.
Yeah, this is basically the visualization, and you can check on the with the red, for instance, the fact that it's.
Show the text?
We have an extra floor in this case that shouldn't be there.
Yeah, for example.
An extra floor. So the IFC file is 5 floors, and the building regulations for the zone allows for 4 floors to be built. So in this case, we identify this extra floor and we just output this information, let's say, message, and the warning that perhaps you need to reconsider. Yes, right now we tried. This building is in Zurich, so we tried to access the building regulations, which is in a PDF format. So it goes through an LLM to identify the exact zone based on the information from the IFC file, and then uses this to output you this message, and also perform the more numerical checks, let's say. Should we give a?
Actually, that already answers part of my first question. So where are the building codes to check for coming from?
Where are they coming from?
Yeah. So you answered it's reading the PDF.
It's fragmented right now. At least in Switzerland, there's not as.
In this case, the codes are being read from the shape files from the city that provides us all the metadata. Since the EFC is geolocalized, we know exactly in which point it is. We can read from that, which is the Bauzone, where this is from the coordinates we can read it, and then knowing this, thanks to the LLM, we can see all the regulations, whatever is required in this zone. Yeah.
I have 2 questions. What kind of tech stack do you use to visualize this stuff there?
These texts this building is located in a specific zone, and that specific zone has some specific restrictions for the buildings. So we visualize those restrictions here.
No, I was asking what kind of technology stack you use for.
In fact, we use Speckle.
The Speckle in the background.
Yes, we pass the FC from the client to the server. Then we have a Python script that deconstructed the EFC and send the mesh to Speckle. And Speckle is connected to Grasshopper that receive the file and process the file and send back to Speckle the file. And then we receive the update in the platform.
Cool. And I think there's a small bug in your program, because if you see the line ground floor area, it reads 232 passes because it is exactly at the maximum allowed value of 250. I don't think that 233 is exactly 250, right? Oh, no.
Actually, I can answer that. 250 is the maximum limitation. 250 is maximum limitation. So 233 is under the limitation, so it passed the check.
Yeah, I'm just kidding a little bit, you know. It's because the other lines it reads it's within the allowed maximum, and there it is exact. 233 is exactly at 250. That's I just stumbled upon it. Just don't take it too serious, okay? Okay. And last question: where's the code now? Could we?
Yeah, it's on GitHub. We can share it definitely. Yeah.
Oh, very cool. Yeah. Thank you very much.
Okay, and maybe a little bit different perspective. We see that the technical, let's say, basis of building permit testing has really advanced a lot in the recent time, and we see that the regulations become more and more available. And just a link, or HSLU Christian Kraft is doing a research project for whole of Switzerland to map what's the percentage of actually machine readable regulations and non-machine readable regulations in Switzerland for our 500 Gemeinden. And my questions would be, how do you enable the participants to solve Zielkonflikte, like conflicts between results? Like we know that a rule to say, hey, do this, and you check it against 5 meters height is okay, 6 meter is not, or that's, I guess that's like a basic starting point, but could you as well take it further to be able to have conflicting whatever rules set against each other and to engage with more complex questions?
Yeah, definitely. I guess we can interactively, I think, make our tool enable for the designers so they can check simultaneously the code. Yeah. Actually, yeah, we have some base rules at this point that, of course, we can add more details and more base rules to evaluate our model correctness on the future. But of course, at this stage, we are coming out with some base rules or some of the base rules. Then at the future, as you see on our future roadmap, we can improve it to increase our correctness and more like validation. Yeah.
I think I'm not about correctness, more that usually in the building permit process, there is a lot of different questions, or is it like too close to some nature stuff? Is it too noisy there? Is it obstructing anything else? And it's like not resolvable by one rule, or it's like 5 rules against each other and there is no rule wins, but it's like about a negotiation between various factors which need a human interpretation that can then be further discussed due to a better base of information. But just a question whether that's in your thinking.
Yeah. I mean, I don't have an answer on top of my head, but I just can think out loud that I think if you have like multi-objectives to like consider, we can maybe also like include in our algorithm and like come up with a multi-objective solution to also like give points or like ratios to the problems that are like more interesting, and also to categorize them like based on the client needs or anything else. But of course it can be done through the code.
So to be respectful of the time, we move on. But like if you could please stand in the middle here to make a picture, that would be amazing. And maybe I ask data blocks to come on stage slowly or get ready. So data blocks. No data blocks? Hello? Ah, perfect.
USB-C, right? Or it's like HDMI?
Hat ein bisschen Wackelkontakt.
It's a website, so it's, if this one doesn't work, backup options.
Hast du auf der Seite auch? Ah, warte mal. Jetzt kommt's.
Das ist der Schluck etwas, jetzt nur Bildschirm kopieren. I can plug in here.
Do what?
Because we can use mine.
But it's working, right?
Yeah, I just need to mirror it.
Ah, yeah. Perfect.
See, got it yourself. So hello everyone. So we're group data blocks. So it's Piotr, Wojtek, and me. And we're a small group, so we decided to not do a big ambitious project this weekend, but keep it small, keep it simple. And we were very inspired by the talks of Friday because we heard like a couple of times like, oh, we got like a shitty IFC and we can't do anything with the data. And then we were like with a beer on Friday talking about it. What can we do? What can we do with this shitty IFCs, you know? Because like in our everyday practice, you know, when we're like designing an architecture project or like we're developing the solutions in practice, like the real information in the IFC has been checked and first in the end of a design phase, and then it's always too late to us. So the whole challenge that we wanted to approach is, okay, which kinds of useful information can we get from really shitty models that can assist us in strategic decisions during the design phase. And you know, we didn't go for like the full startup potential this weekend. We were mainly aiming for like a strategy that we could really use in our everyday lives from next week. And for that, we had like lots of conversations and lots of iterations where each of us would play the role like, oh, would we really use this at Monday? Would we? And so we skimmed down a lot. And in the end, we came on this one big topic that's like a big hurdle in all of our lives, which is this topic of model-based gross volume calculation. And you know, for us three, how it works in everyday life, you know, when we're Monday in the office, we have a client, they want to have this value, where, for example, I have like a Revit model, is that in practice, we're like redesigning, like the remodeling, like a mesh around like the existing building, and then we're clicking on it, and then it says like volume is this, and like we're all working in different softwares, but like the workflow that we have like is all in a similar way. So from like all these 1,000 ideas, this was like the main thing that we're like, okay, this is small, and we're all confronted with it. And we want to give like an alternative, a flexible and a robust way to solve this kind of calculation, like in the very early design stages. So when we're working with SketchUp models, when we're working with 20 alternatives, and we want to get some kind of data. And the main approach that we went for is simplifying the model just purely based on the geometry. We ignore all the information. We ignore all BIM modeling standards, you know, over the border and between companies. There are like 1,000 different rules how to model roofs, how to model walls, and we just brute force do it like in this pixelated format. We went for like this pixelated format, you know, just because it was the first thing that came into our minds. You could also use shrink wrapping, but like a simplified geometric approach. And then we were testing, okay, what can you actually do with this very simple geometric approach that's always consistent, independent of the software being used, independent if someone is working clean in the model, it's very early, it's very there, and you can read it out every day. So like for today, like to make it a little bit more sexy, we made like a small website to display how we just envision it, how this could work. In practice, we did like the voxelization in Grasshopper, but let's imagine this is all working in the web, like in 3JS. We're opening like a model. It's voxelizing it, and the idea is that you get like basic quantities, simple quantities, that's still better than nothing. So how we see this in practice, like every day you can take snapshots of your Revit model, save it as an IFC, force your colleagues to save an IFC, and then in the background on the server, you've got like a parser going on that's reading the IFC models or the SketchUp models or the OBJ file formats. And it's in the morning, for example, in a displaying in a dashboard or an email, just sending these basic values. And they're a rough approximation, they're probably 10 or 20% off, but they're there every day, they're constant. And they might aid to guide like a more low-tech project leader to decide, okay, is my project going in the right direction? And is my project, that's one of my 20 projects, going in the right direction? So like of all the 20, 30 kind of parameters that we were philosophing about this weekend, these were like the 3 that were judged as like, okay, you could really calculate it from this very simple geometry. So the first one was like the gross volume that we were talking about. Second one is like the building footprint, also very simple, but also something that's very manual. And the third one is like all the surfaces or the roof surfaces and the small canopies that are like exposed to the weather. And you know, if we would have more time for the future, you would have like 2 or 3 more hackathons. Then you know, you could also get like these kind of ratio parameters to judge if it's like financially worth to process this design phase further. And we imagine it that you can like view the calculation model and see like where these quantities were calculated from. So you can have like a visual double check what these values are worth. Keep it short because of the time. Thank you for listening. And questions are very welcome.
No questions from the audience. Can you take us one step back and say what triggered you to get into this? Where do you see a real world problem coming across that was the starting point for your thinking?
So one real life scenario where we're confronted with this is like masters for cost calculation. And we often, like in the calculation software, you've got like some kind of value that's generated. Sometimes you have to write it like in the IFC masses. And then there's always about 1 or 2 positions, for example, with calculating soil extraction, the volumes of it, like this question, this paranoia, like, is this value real or not? And this additional way of calculate it, we see it like as a good possibility to do like a quick emergency double check to see if the values are okay-ish or like a factor 2 or 3 off.
Okay, and the quality gates that you are defining, are they like defined by the user that then does the tests, or are they just like gates that you would suggest? Are they like defined, like derived from the model itself or from the process itself?
So what we see here on the screen, like we didn't implement this one, it's just like for the future. This is based actually if you're doing residential building planning in the city of Vienna. If you do like social houses, there's like on the, like there's like a website of the government and they have like this list and like all the clients that are into public housing there, they have this one. And if you're doing residential architecture there in the city, you have to fill in these values every week in an Excel sheet.
So the quality gates that you have, or the range that you're proposing, is that the range derived from your suggestions, or is it
No, it's from that single document. So the only thing that we added here was like the result thing. That's just, you know, it's just a placeholder.
So that's like the benchmark.
And everything else, like also the numbers, that's what you do like in Vienna, like on a weekly basis.
It's like the benchmark, the way
exactly, or at least it's a standard that a lot of people know.
Okay, and how many models are, or would you expect in such a setting to be tested?
You mean in like a parallel, or
yeah, like in where I'm coming from is like if one has like very few models, or and I need to check something, and probably need to check it precisely. So that's probably not going to be my approach. But where I see great usability is if I'm in the process where I have a lot of models, and I cannot communicate a lot of standards, or I don't want to because it's maybe early stages or something, and I want just to process a lot of models against some benchmark with less effort. Or we see this in architectural competitions when you have whatever 100 submissions, and you don't want to spend too much time on quality checking or even improving the models. You have no time for iterations, but you need to have a certain quality gate like on the step or like immediately.
So we are imagining like all the projects in the company. So let's say 200 IFC models overnight every day.
Interesting. Yeah, thank you.
So
last question. So what's next? What are you going to do with that?
Probably have lots of discussions about what is really viable on this this parts in the formula to extract, because we spent lots of times like on the detail how much you can trust these values. So that's why we skip most of the list. And probably probably like a handbook how to approach this like in a software neutral way. So others here in the room can do it in like in Rhino, can do it in ArchiCAD, and it's more flexible than just one super plugin that you need a specific software for.
I mean, just a final comment, or we see that normalization in models, or it becomes more and more relevant when we cross borders in processes from one whatever environment to another, and there is a big need for solutions that can address that. Also, great work, thank you.
All right, thank you guys. Please, if I can ask you on the stage as well. Awesome. And then I would ask Connection Found to get ready. So Connection Found.
Okay, thank you. Hello, everyone. We are Connection Found. Team industry needs kind of development to have a clear physical and digital connection, to have a seamless collaboration between like them and their partners. Identifying and quantifying and categorizing all the connections within the building components are important in order to enhance this coordination and integrations. To quickly just show where the problem lies, it usually starts in a way that external planners delivering all the files to the commercial department to internal digital planners. And during this back and forth process, they give kind of an offer to external planners. And this offer is not accurate all the time because they don't have kind of an accurate number of the connections. And that's important for timber industry because they give that offer and calculate all the costs based on the connections and everything. And that connection is important, but is not always accurate. And at the end, oops, they face the over budget situation. So why? Let's just fix this situation. In order to do so, we thought we bring all the connections more in the process, the connection analysis, in a way to import the IFC model to the web IFC to web browser and start the core processing there, where we use the collision detection and raycasting to detect all the intersection and have them as an like points, lines and surfaces. We also have the option to upload all the components catalog to do all the match intersection later. We can quickly match all the intersection with the components relatively in the catalog. And we have our visualization and UI web-based and export all the connections, all the connection details as CSV and IFC5 files, and have all the connection analysis and details as kind of a snapshot, as PNG files, like images. And that's the way that we are doing it.
Thank you. So,
in order for actually we made some assumptions for our approach, and these are two important ones. One of them is that we assume that the model that we get from the architect is a clean one. And the other one is that we made a small tolerance for the detecting the intersections between different parts. So these are the two important assumptions we made. And regarding processing and analysis, Parisa already gave us some hints about it, so I'm not going too deep in that. And at the end, the results are visualized in our web-based UI, actually. So here's a small demo of the process and how it works. It's a video, but Louis can show us live how it works actually. So here's the interface. You can load your model here, and as you see, there's this 3D model generated from the IBM. IFC, sorry, from the IFC that is loaded. And yeah, if you click this button here, all of the intersections are analyzed, and you can see all of them here. So, and also the type of connection, like point, surface, line, number of them, etc. And yeah, and if you click on them, it goes in details and show you the connection. Yes, that's it. And yeah, and the other part is that you can also load a PDF that contains the component catalog. That's there. It's in desktop, Louis. If you go to the sure, yes, exactly. So if you load that, if you go to the sections, you get a preview that this type of connection or component matches with a type of connection that we already have in our component catalog. So you get directly a preview from it. Yes. That's it. Thanks. So I open the presentation again. Okay. Yes, sure. Sorry. Yeah. So pros and cons of the approach. So the tools that we use are all open source. So that's a big advantage. It is fast in loading and showing the preview. And it is also user friendly, as you see. So there is no high-tech knowledge required for that. As cons, so as already mentioned before, we have low precision for detecting the intersections. The tolerance was 10 millimeters, which can be higher, definitely. And it is strongly IFC dependent. So if we get a high quality IFC, it would work perfectly fine. And another thing that I want to mention is that our team was also very multidisciplinary. So we had timber engineers, we had software developers, we had computational designers, all of them in a loop. So we could evaluate this approach pretty well. So
just very quickly to wrap up, because we're out of time. So what about the future? What we thought is that there's small improvements that we could still do relatively short notice. But like on the long term, what we think is adding like a graph-based detection and categorization system together with historically tracking and matching the projects of the industry in general or the specific company, combining it with machine learning and LLM would be very beneficial. And that's it. You can find also our GitHub repository and the platform if you scan the respective QR codes. And yeah, that's the team. Oh yeah. Any questions?
Oh, yes.
Yeah.
That's what I looks good.
Any questions from the audience first?
Very impressive. Question is about the catalog. Did you map the details against the name, or did you manage to retrieve information looking at the detail?
No, so it's mapped by name, basically. So the name matched on the IFC processing is matched with the catalog, basically. Yeah.
Any other questions?
Okay. You have a lot of experts from the industry in your team, obviously, and we see that this is a real life problem that you're solving. What triggered you to select that problem to be solved? No audience answers. Team answers, please.
Yeah, personally, I think like it was something that was tangible for me, like seemed like, okay, very useful for someone else also. And I thought that there would be something that I could also take myself for my further work now.
For me, as an engineer, it's not only the costs where we need the information which parts stick together. We also need it for static calculations, and I'm looking for this one.
For me, it's pretty simple. I think it's called nerd sniping. I've just found it an interesting problem.
Yeah, kind of same here. I like to find tools or like workflows for like real life problems, and that's one of the challenges that timber industry faces like now. And yeah, I
Okay,
thought
thanks.
it's a cool challenge.
Thanks. So for me, the thing was that it seemed an easy challenge to overcome, but Fabian and other guys mentioned, no, it seems easy, but it's not easy if you go deep into it. So that just encouraged me a little bit to have investigated.
Thank you very much. So I don't have a question, but just a remark. I'm really proud of you. You not only solved the problem of finding the connection, but also implemented matching with the catalog already, which is fantastic. So big applause for you.
Thanks.
Thank you.
All right. So find the connection. Please get ready.
Hello.
Okay.
Hi, everyone. As you may have noticed, we've shrunk a little bit, but I'm Chem.
And I'm Ian.
Yeah. We chose to address the same challenge as the previous group for different reasons. We ended up splitting. I think first day we seemed to have a lot of people
for the same challenge. So we split into 2 groups. Right. Early in the early hours of yesterday, when a full day of work seemed like a really long time, we chose to try and address 3 different challenges as part of the connection discovery problem. The first one was to address the very realistic situation where an IFC is too shit to perform the connection detection. The second one was to use an ideal IFC file in order to try and find connections. Yeah, and the third, so yeah, find the connections. And then the third challenge was to try to categorize the connections based on the elements that they connect and their geometry. We ended up working on one of those 3. And this is the finding of the connections. And I will let Yen now talk about the solution.
Okay. So instead of ray tracing, we do more like a arithmetic approach. So first of all, we extract the IFC data, and then we get the geometrical data. And also with that, we also get the property sets. And actually from here, we will test the intersection, basically what is near, because in the IFC model, actually each entity is not aware of they are being near to. So basically then from there, we create a new graph structure. And from this graph structure, we traverse through it to get direct and indirect connection. So basically in the ideal structure, it's like this. We have the original IFC object, and we, through a dictionary, we create a new node. The reason why I create a new node is because I don't want to traverse through the IFC API. And so I just create this graph structure here, and then basically every node is aware of what is dot near. So in the future, of course, you can turn this dot near into a vector. And basically, because not everything is like a dot near, or maybe it could be dot up, dot down, something like this. So from here, so while every element is aware of what they are being surrounded by, actually one of the problems is that they don't know about a corner, because a corner is created when 3 elements join together. So here we also have another algorithmic approach, which is we find a loop. Basically, if there's a loop and the element comes back to itself in 3 steps, then there's a corner. So here you see the wall, node A to node B to node C. If node A is also in the next step that it could take, then there's a corner there. And also one of the criteria is also that it has to be either a slab or either a wall. So this is the algorithm that we are testing. Not everything has worked, but I will show you what has worked and what has not. So this is also basically based on this is a very simple like a depth first search problem. So but with a depth of 3 or a depth of 4, and a depth of 4 you can see here, which I draw 1 minute ago. Basically, it's when there are. It's also common in the construction that there is like where the connection of the slab touching the connection of the wall. So this is, but commonly it will only be 3 to 4. Yeah. So maybe I will just very quickly. We didn't have much implement. Well, we implemented the code on my. On my notebook. So basically, I can walk you guys through how I did it. So basically, of course, traverse through the IFC. And then we basically do like a buffer search here to go over all the elements of all the level. And then there we get the geometrical data. And there we kind of get the geometrical information. And from this geometrical information, we also get the property set. And from here, we write it down to the new node structure that we created. And from here, we also then get, I was very naive because I calculated the global coordinate for all the vertices, but then this comes really with the bad IFC problem, which is the things I actually not touching. So when they are touching, of course, I can get like this 4 corner here telling me that this NumPy array, they are touching at 4 vertices, but the reality is they are not. So, but still we can at the end get, this kind of connection here. Basically it's what are touching each other. And basically from the loop detection, we also get in what roots there's a corner existing here. And one last thing that we implemented with this here is that we have like a, so this is a material product extraction. So basically it's very simple. I just do like a rag approach. First use an OpenAI key, like always. I put it to an LLM, and then basically I first summarize everything and tell me from the catalog, can you turn it into a smaller summary, because catalog is always very large. And then I turn this into a vector. and then turn it into like a vector DB, and then basically by the query of like what is the best connection type of the entity A0 with property set 0, and then they were gonna tell you which documents to look for it. What? We have yeah, we are out of time. Yeah, so that's it. Yeah, right.
Thank you, guys. Any questions? Yeah. Anyone else from the audience? Otherwise, we can go to the jury. Questions?
So thank you very much. Even taking out the risk to embarrass myself, I want to ask again, the main problem you tried to solve was improving connection detection or interface detection in the IFC. Okay. And you based it on geometrical rules, like a corner has 3 surfaces to meet, for example. Coming now from an industry who was building a lot of free-form projects, actually that's a rule that does or can be applied on standardized projects, but I had many where a corner was not defined by 3 surfaces meeting each other. How would you deal with that kind of problem geometrically?
Actually, when I mentioned why they're like a corner defined by 4 surfaces, right, or even more, right? Is it right? That's the question, right?
Yeah.
But basically, I think the idea is the same. So basically, the idea was finding in each step when it will return it to yourself. So, and then we define that as a corner. So basically, in the idea where, so here we define the corner as in here. So node A go to node B, go to node C, go to node A. This is like a very common kind of wall settings, right? So A to B to C, and then back to yourself, and then say, hey, there's a corner, because there's also a slab and then a wall in the middle. So I think the condition is basically how many steps you want to traverse before coming back to yourself, and in which is there going for a slab. So if in that sense, then we could define there's a corner. So that was like the how do you say, the generalization that we did. So in your case, if there's like 5 walls running together, it would be like take 5 steps and see if you can come back to yourself.
Yeah, maybe, but it is maybe not a wall. It could be part of the roof or any kind of.
Yeah, but it's the.
But yeah. To get it correctly, you're building up a catalog of geometrical rules to identify your elements or interfaces.
Yeah, so I think the challenge was that we need to identify where are the connections, and to do that, we do it more like a geometrical way of finding the connections. Yeah.
And how far would that be an add-on to the project that we just saw before your presentation? In how far would that be an add-on to the presentation that we just saw before?
Would how far be there?
Yeah, like that logic that you're applying, like the project that was presenting before you, or was as well like referring to similar questions?
I don't know. If I'm not mistaken, they didn't exactly say how they technically found. I think they use ray casting. I think one of them mentioned yesterday. Yeah, they use ray casting. We used a different approach, basically finding overlapping vertices between the whole geometries. So yeah, where our overlap is in the technicality of finding the connections, where we just had a different approach.
I think we get a live insight here.
Yeah, just wanted to add to that. We realized that the different approaches worked differently and gave different results. For example, we had trouble finding intersections between beams and walls, which was really straightforward for them actually. So it might be really beneficial to find a way to combine both approaches.
I think back to the corner problem is that if you use ray tracing based on like how many area you want to cast how many rays on, if there's only one single point of connection, there's no way you can cast a ray on it, and then you're expecting it to bounce back. Yeah. So
one last question.
Yeah, I have a question regarding the computational complexity because you run it on Google Colab, so I guess it's quite complex. Or did you measure it? Can you run it on your local machine? Whatever you did.
I think for just the reason why I didn't want to run it on my local machine is because I didn't want to like set up the environment. And
Okay.
yeah, so I just.
But you could run it in the normal.
Yeah, of course. But also from like the vector database query, I didn't run it on my local machine is because I don't want to download the weights for the mod. Yeah.
Okay, thanks.
All right, thank you. If you could maybe also stand on the stage, please. And next up is graph comparison. If they could get ready.
Super brilliant. Very nice. Good job.
Ich will auch noch eine Stopwatch laufen lassen, dass ihr habt.
Sehen oder gibst du mir ein Signal?
Zeigst du noch.
Okay.
Ja.
Jetzt? Ja,
Perfekt.
Good afternoon, everyone. My name is George, and I'm with the Graph Gang, I guess. We have a terrible name, as you can see. But before we get to the graphs, I would like to introduce you to a high-level problem that we're trying to figure out and deal with, which is basically similar to what we've seen before. So basically skipping the gap between, let's say, traditional planning and industrialized pre-production. So that's kind of where we want to get. This is a big issue, as you guys know. But before, like, we won't get there. That may be before, and we can't be able to get there within this weekend. We get started with very few things that we got from Implenia and ZHAW, which is random floor plans, 2D. We got reference designs that are prefab ready, so can be built, and we have an interpreter, and now we come back to the graphs that can make graph representations from 2D floor plans. What do we actually wanted to do this weekend? First option is messing with the graph setup. A couple of things. First one is simple question, are two rooms adjusted, right? You'll see why that is relevant in a second. The core issue that we wanted to solve is matching the floor plans that we got from external sources and, let's say, the elements that are prefab, and try to put them on top of each other and see how similar are they. And then we had a couple of bonus things. We wanted to estimate which walls are most likely load-bearing in that setup. And that's something that I got earlier. It might be good if there's actually doors in there, so you can go from A to B in individual rooms. And I'll hand over to Marco to give us a quick overview of what we achieved on the graph setup and how we improved that.
Yeah, very briefly, we solve the room adjacency traversing the graph and find out which elements are in which wall elements are in both. So pretty simple. Another thing that we did is we are starting to group our graph into a subgraph that Diego will explain in a second, into small constructible units. Our bigger problem is we don't want to sell ship to we want to ship air, want to ship construction, so we want to compact the cores, the modules that are technological, complex, so bathroom, kitchens, and whatever connects them. How did we do it, Diego?
Yeah, so we're gonna show a quick demo about our implementation. So here you can see on the bottom multiple generic plans, which are what you want to test, basically. And then we have some metrics, which are your plan, if it has 2 apartments, the amount of modules that your prefabrication has, and then some similarity matrices that compares how similar these floor plans are to your prefabricated designs. So here we can see like all the plans that are very similar to what you want to ship. So basically, if we have corridor, bathroom, kitchen next to each other, that's really good. And you can also see some other examples here. This is like the perfect case, but we can also get something like this, where we have bathroom, corridor, and a bathroom next to each other, but it matches quite good your prefabrication. And then you can see how that floor plan matches with what you want. Yep.
All right, thanks, Diego. We have a minute left. We do have a couple more things we wanted to show, but I need to go back to the presentation. Unfortunately, I don't get it mirrored on my screen, but we'll get there. All right, so you saw the demo. The next thing that we had another approach that Chris will summarize quite quickly.
All right, so we cared not only about the adjacency and the graphs, but also the geometry itself, because it matters, like the metrics of the model. So we prepared a few tools that may help with finding out what is the similarity between the designs, not only, as I said, in terms of adjacency, but also in terms of geometric similarity. So the main algorithm works in such a way that first it finds the best alignment using an adapted ICP algorithm, which we had to adapt to ensure better the better alignment, which is once again, as you can see. So every room tries to get as close to another room as possible, and the score that you see here is the measurement of the translations that needs to be done in order to get to the reference design. So this algorithm can be also, we tested it, it can be applied to full plans, so it finds the best match between the candidate and the reference. And then we measure the similarity as well in terms of geometry. So how much do we have to shift the walls of corresponding rooms? For instance, you can see that the bedroom has to be translated to another bedroom, the core has to be translated to another core, the bathroom has to be translated to another bathroom, etc. And we optimize that all by adjusting the metaparameters of the ICP algorithm. And in the end, we get a similarity score that is complementary to the adjacency, that tells us how much the geometry differs in terms of access between the reference and the candidate design.
All right, thanks. That's it. One closing remark. That's not the end of it, because this is just a means to an end. We're missing connecting a kit of parts which would enable us to populate good candidate for plans for pre-production. And that's it. Thank you very much, and we're happy to take some questions.
Maybe some questions of the audience. Then, if not, we go to the jury, if they have some.
Not so many questions from the jury. Can you explain one more time, like the evaluation that you showed, or you had this benchmark with point systems? How do you distribute, or how do you come to that evaluation from the matching of your plans?
You're referring to this, right?
Exactly. Yeah.
We check the adjacency of every room. We're focused on the bathrooms and then how they connect, because from the kit of parts perspective, they are the most, let's say, they're a volumetric module that can be translated in the volumetric model, and it's monolithic. It doesn't change so much in size. So we check first the area, the adjacency, then the areas. We compute, so we check bathroom plus corridor, bathroom plus kitchen, 2 bathrooms, different combinations of that sort. We exclude living room, bedroom. We take the areas and we take the bounding box of all the rooms adjacent, and then we compare the individual areas with the bounding box of all the 3. And that's the first metric. And in the case of a design that is, let's say, the reference, this is almost 1, because that's like the target, let's say, what you see there. Bathroom, corridor, bathroom.
Okay,
so if it's like closer to 1, then you are more similar to that. You're never close to 1, then we're weighting it a bit. And the optimization comes, okay, if you're not close enough, how much do you need to stretch?
Okay, so you're basically coming with a hierarchy. You say, okay, that's my priority, priority 1, priority B, second, and so forth. Yeah. And then you basically go down by once something is set, you add other priorities, and from another.
You improve the ranking. You start with a more, let's say, dummy ranking, which is what I described you, and then you're trying to refine it by, it's more optimal if you pack 2 bathrooms in the module. So, and then the other is if you're close to the area of the module that is given by Implenia, which is that monolithic, let's say, block of a certain dimension. And yes.
So as far as I understand, Implenia has some specific arrangements of the modules that work best for their designs, and the whole point of this thing is to see how the candidate designs fit in that system. So all the metrics are based on the reference which is best for prefabrication, and then we see how much we have to adjust the candidates to get the best solution, which is
the challenge was to be able to give any plan. The plan is something maybe that we didn't translate. Instead of taking it geometrically, we convert it to a graph. And then we started comparing the graphs, and then we bring it back to the geometrical, let's say, comparison.
I'm coming from the point that like we have a lot of refurbishment projects in our whatever built environment, and the matching of potential new uses into existing environments, or could be another just way of thinking of.
Yes, the more you go with more rooms, the harder it is to find the matching criteria. We had this problem with Christoph, and then the moment we started, when we tried to do the whole floor plan, it was tricky. We didn't converge, or we didn't get some good solution. When we reduced the number of rooms that we're trying to compare and match, we got some better results. The challenge was to be able to rank and have some confidence that some random design that you split, it's a go or a no-go for prefabrication. And in that sense, we tried 3 different approaches. One seemed to work quite well. I mean, it's one day, so yeah. There is a lot of room for improvement, but yeah.
Thank you so much. Very cool. Thank you.
All right, so let's move on. Please go on the stage. And before the break, we have Smart Search.
Let's go. That's what you guys wanted to have, right?
All right.
Yeah.
So I will show like a little timer, so you have like more like approximate how much time you have left. Really takes a while.
Hello, everyone. We are group Smart Search. We have been a very small group, but diverse group, consisting of Jonas, data scientist, Andre, a civil engineer, Elias, developer, and myself, an architect. The challenge we approached is that construction industry often gets accused of producing prototypes all the time. And I believe that this is not always on purpose, but is often also caused by not being able to access all the knowledge from past projects, which is stored in graphical data. Earlier on it was paper, nowadays it is PDF or image files. And this is causing the problem that we need a lot of time to search information and have no structured way to access it and sort it. And it also requires expert knowledge to find the right clues to use it to produce better projects or reuse the solutions that had already been found. This is what we try to address, unlocking the treasure of the knowledge of past projects by combining an LLM with expert knowledge and graphic-based knowledge, meaning searching like images. And that's what we did. Like it's a rack approach as well, as we heard earlier on. So there can be like a prompt graphic-based or text-based, and then it is being analyzed whether it matches some categories from the database. And according to the matching category it finds, it also adds the specific expert knowledge. And then this enriched prompt does the query searching either the world, like World Wide Web, or a local archive of project data, be it image-based or text-based. It's just a very quick run through in images. So this is the example we used, the construction details, the workshop drawings, because in these detailed plans, technical drawings, there is the most information, as the most knowledge. We took 4 examples of typical construction situations and trained, like Jonas actually analyzed these images. First the graphical analysis, but then also did a text extraction to get keywords out of these typical construction details to be able to recognize them with this analysis network technology. And we did get some success there. The training was improving, like the loss was decreasing and accuracy increasing. And here, Jonas can take over to explain.
Right. Yes, so just to show how you can use the model. So now the weights are frozen, and basically we have some 4 categories that we're going to identify that the model have been trained on, loading the model, and then you just have to point to a PDF, which will be converted into an image format that we can analyze. And then we get the category out as an output. So like that, this can be interfaced with a chatbot, for example, through Langflow. Yeah,
so that the chatbot can give more relevant responses.
Thank you. Yeah, and that's what it was previewed to, that we could combine these results from the category matching with further text-based results, the expert knowledge that can be sorted also category-based or can be enriched by each company, by the specific experts to enrich again the query and then generate a more specific query. And Elias then put together a chatbot that can already with the first prompt generate very relevant results based on expert knowledge, very narrowed down results. With this, we think we are on the way to unlock the treasure of hidden knowledge in construction industry, and yeah, are happy to receive your questions.
Questions from the audience? Then maybe jury questions, if there are any.
Just a small question. It's a little follow-up from last year's SCR sourcing project that we saw. We had like two challenges last year. Was the ownership of the actual real relevant information, or as long as it's not really public, then you have a paywall challenge there, or could you say something to that?
It's the same challenge. It's a regulatory challenge. So yeah, and with this image interpretation, it's easier to search local and to source on local knowledge to bridge this gap. But this is not, it hasn't changed in a year. We cannot reach through the paywalls, but we can search in each image based on the local archive. So that is maybe an additional value.
Okay, it's maybe a bit of outside comment, or maybe it would be interesting to make a project around how to make it actually available, not from a legal perspective, but from a how do you distribute the whatever values to actually make it publicly available. And the second question is, when you think of the reliability, you said you had a validation, or is it actually kind of giving out an idea on how valid you would say that that information is? It like 10% valid, or 50%, or 90%, or something? How do you look at this? Or does it need experts for that, or can you do that automated?
Maybe the first disclaimer, we have trained on a very little amount of data, and it was a lot of timber-related construction details, just to make be clear about that. But yeah, the rest, Jonas has to maybe explain.
Yeah, I mean, let's say the model needs some more tuning. Mostly it's there's not enough data, I would say, but it does give, let's say, some accuracy, and I think one can get more value out of it by combining it with the keyword analysis. So now we didn't quite have time for that, but ideally it would be good to extract the keywords and put that through a separate model, and then to combine basically the output from that model with the image analysis. And then maybe like this, you can achieve better accuracy and better characterization.
This is image showing what we just explained. So far, we only had the time to train on the graphical screening, and it would be added value, or would, of course, increase the quality of the results if we could include the keywords extracted as well, with more resources, more time.
Also, one challenge will be that we have now this layout of the detailed plan, but when we increase the database, we will have different layouts. And then because we try to extract actually PDFs from different informations sources, but it was not reliable since all were kind of different, and the program will have troubles finding the relevant information.
Thanks. Just to add, or why I believe this is important, or I mean, we have globally so much information available, but it only gets interesting once we know how viability it has. and to give it a certain twist into the direction. Okay, if I want to use that, I don't need to plausible it myself whether it's actually good or works or will have had any other problems. I mean, what we have about details is about what experience is in there from other projects which have caused problems or which were successful. Or so if one can whatever take this further and give it any notion in that direction, it could be incredibly interesting.
Yeah, maybe just a little add in here. That was the idea. Like one was like the information extraction that could be added to the training, and the other one could be if the category is recognized, also to add the specific category knowledge, also to train it again based on this to ensure that it's really expert knowledge based.
Maybe last response.
Yeah. And this expert knowledge database can be increased. Like now, Anne filled a lot of keywords, but this we could make even a platform to increase the information on a different category.
So if you could move to the stage. And after this, we have a 15-minute break. So maybe it's start at 3 o'clock again. Yeah, I mean,